Hello everyone. So today I'm going to discuss about Feast. So Feast is nothing but an operational data system for managing and serving machine learning features to model in production. So in today's discussion, I will be using diabetes dataset for the live exercise. Okay, so let me start. So let me quickly open an Anaconda prompt, and from there I will go to this folder. So I need to go inside documents, then Feast and Feast demo. So this is a like folder I have created. So you see here in background. So there is nothing, only I have the data diabetes data set and the live exercise, so which I am going to show what is there inside. Okay. So let me open the Jupyter notebook quickly. So one more thing, guys, I would suggest every time when you are doing any project, so please do inside any either Conda environment, virtual environment, or any kind of environment, so that whatever dependencies libraries you are installing, it will be installed inside that particular environment, and it will not affect any with any other dependencies installed within the system level. Okay, so let me so I have already created some of the environment. So you can see Conda environment list. Using that, you can list all the environment available in your system. So like I have these two environment created, and base is the default one. So specifically this MLOps I have created for this exercise. So let me activate that one. So using Conda activate, you can activate the environment. So Conda activate MLOps. Okay. So now you see environment got changed here, and now I can open Jupyter Notebook from inside MLOps environment. Okay. So this is the very important and common thing we do before starting any project. Okay. So now if I hit enter, then it will open a new Jupyter Notebook. Okay. So it has opened. So like this. So here you see it has opened the same folder, which has a diabetes dataset and this exercise file. Okay. So if you are interested in the practical one, then I would suggest please you also open the same thing and create a empty notebook from here, and then do along with me. Okay. So it will be a completely hands-on session. So you learn along with me. Okay. So I have created some content as part of this notebook. So nothing but the agenda, basically what I'm going to discuss on this it will be around 40 to 45 minute session in this session. So I'll be talking about how to prepare data set and store in Parquet format, because the Parquet is the format which Feast expect, and then they will initialize the Feast library and update feature store YAML file. So what is this I'll be talking about? So this get generated as part of Feast init. And then next step, I'll be defining some feature definitions, which will be stored. Feature definitions are nothing but the set of columns, set of features out of our data set, which we want to store inside the Feast repository, so that can be further served as a training data set and for online prediction as well. Okay, so I'll be talking about each one of them in detail. And then we'll do Feast apply. Then we'll generate the training data set. Then we'll do model training, and then prepare an online feature store. Okay, so I'll be discussing all these in detail, and then at the end we'll get online features for prediction, and we'll do the prediction. Okay, so this is the complete end-to-end flow I'm going to talk about. So I'll build one basic model also. Okay, so this is the thing I'm going to discuss in this video, and what I'm not going to discuss basically. Okay, so in this video, I'm mainly focusing on the practical part. So not going to cover the theoretical concept, but if anyone wants to go through, then we have a very well prepared document from the Feast itself. So they have explained like what is Feast all about, and complete architecture, and what kind of problem Feast solve. For example, the consistency among the data, like which you are for example, you have some data for training, and you have some data for model prediction, right? So distribution, all the data properties should remain same. So data set should be consistent, right, among different stages of machine learning. And then deploying new features into production is difficult, right? So that also taken care by this model. Needs a point in type correct data, right? What time of data during what time of data you want for the prediction. So that will be taken care. And features aren't reused across projects. So what it is basically, so you have some features stored, and suppose you want to use them across different teams within the organization, then Feast provides this functionalities also, right? And then again, what problems it does not solve yet. So like feature engineering, feature discovery, feature validation. Okay, so you can go through these theoretical concepts. And for Feast is not all about like ETL or ELT system. It is not a ELT or ETL system. This is not acting as a data warehouse, data catalog, all those things, right? So you can go through that one. I'm not going to cover that one, but I will be covering the practical aspect of this. Okay, so let's start that part quickly. So I'll be going through these headers one by one. So let's start with preparing the data set. Okay. So I would suggest please open the notebook and do it along with me. So let me first import some libraries, the important one like pandas, so which will be used for reading the data set. So I have installed these pandas within my MLOps environment, but if you have not installed, then of course you can do pip install pandas, okay? So I have diabetes dataset, so diabetes.csv, I will read it, okay? And you can quickly see like dot head. So we have these many columns, okay? So like pregnancies, glucose, blood pressure, skin thickness, all different parameters. And based on that, the expectation is our model should predict like whether a person has diabetes or not. Okay, so that is the target variable, that is outcome. 1 means yes, he has diabetic, and 0 means not. Okay, so in this, anyway, I'm not going to explain the modeling part that I'm expecting you already know, but I'm more focusing on the feast part. Okay, so I have read the data, and data is now available within data frame. So what next? So let me quickly segregate the predictor data frame and target data frame. So predictors will be containing all the predictors. So we can do data.loc, and here I can get all the data, I mean all the columns except the target one. So what I can do, data.columns not equal to what is our target column? Outcome. And then similarly, we can have our target data frame. So what that will look like, simply and data, and we can pass outcome. And if I quickly run this, then we'll have predictors data frame and target data frame individually. Okay, so yeah, and if I quickly show that also, dot head. What happens? Oh, it's not heads, it's head basically, right? Okay, so now we have all these columns, like all independent variable in one data frame, and target will have only outcome variable. So now the next important thing what we need to have here, basically the timestamp column, which is not by default available with our data set, right? So we'll create, I'll be talking about why we need this. So let me first create the timestamp. Okay, so what I'm doing here, I'm creating a timestamp variable. So what it will be like, end means pd.timestamp.now. So it will have a current timestamp, date time, and then period, like length of data. So how many timestamp values we need. So like the length of data. So how many rows are there in our original data set? So those many. And frequency, like day wise. Okay, so like today, yesterday, day before yesterday, like that. Okay, and then this list of like dates with timestamp, we are converting to data frame. And that column I'm giving name as a event timestamp with index is equal to false. Okay, so it will create a timestamp variable. So let me execute it, and then let me quickly show you what values will be there. Okay, so like you see, event timestamp is coming from this, as we have defined the column name as event timestamp. And here you see like frequency is divided like 21, 22, 23, 24, like that. Okay, and then we have a time variable as well, date and time. Okay, so this is the timestamp variable. And as I said, why we need this? We need this timestamp because later we will be needing like these data values or these records are created at what time. Because when we are going to predict, so we will be needing a data for a particular time, right? Because most of the time we need the latest data, because we are predicting on current data, right? And historical data we will be training our model. So for that purpose, we will be needing this timestamp variable. Okay, so now you know why we need this timestamp variable. So we need to append this timestamp variable to our data as well. Okay, so what I will be doing, so in both predictor data set and target data frame, we'll be adding this timestamp variable. So let me quickly add this. Okay, so predictor df will be equal to pd.concat. So I'm just concatenating this timestamp variable at the end. Okay, so and let me give x is equal to 1 means column wise. Okay, and similarly we'll do our target df equal to pd.concat. And if I quickly run this and I show you, then we have a timestamp variable added. Okay, and similarly I can show you the target data frame as well. Okay, so now even timestamp, as I said, like this timestamp will be needed at the time of like prediction. So when on what particular data item we want to predict, so like we'll get that those data item between some date, right, or the latest one. So that time we need this. Okay, so that's where I've created like what time this row is created. And in real time, real life projects, you will be having this information like when this record is created, right? So it will, so this timestamp will be of that time. So now one more thing I will be needing, because see, we are preparing the data. So our data was raw, like only containing this much information along with the target variable. But for fish to work, we need two more variable. One is like timestamp variable, means what time that record is created. And one more variable like the unique ID, which will denote this each and individual row as a uniquely. Okay, so let me create a unique ID for each record. Okay, so this is a medical history of the patient. So let me name it as a patient ID, and let me create it. So how to create basically? So again, the ID, so similar to a timestamp, like here we have created the length, right? Length of data. So those many timestamp we have created. So similar to that, we need those many IDs, randomly generated IDs, right? So for that, what we can do, we can first calculate the data length. So that is len is equal to data. It will have data length, and then we can have IDs. Okay, how many IDs we want? Okay, so IDs list. So we can create a list with the range as data length. So we'll have IDs available with us, and if I print that, So we have these IDs, okay, in sequence because we have used range function. So it will calculate 0, 1, 2, and up to how many are there, okay. And then what we can do, we can generate a proper patient ID. How? Let me show you. Okay, so what I'm doing now, I'm creating a data frame out of this so that we can easily append there. So pd dot data frame, okay, and we can pass data as IDs list, and again we can define column as patient ID. And now if you again print this, okay, so here you see like we have a patient ID is generated, right? So the length and or count will be same as our data. Okay, so now again, as we have added the timestamp thing to our both predictors and target, so we'll add this patient ID as well. Okay, so I'm copying the same line of code. I will just simply change that with ID list, patient IDs. Okay, so that I don't need to type it again. Yeah, and let me execute this. Okay. And then again, I will show you quickly what is there in here. Here you see, we have event timestamp and patient ID added. Okay, so now patient ID will uniquely identify this record. So sometime what happens now, two records are created at same time. Okay, so this event timestamp might be same. Okay, of course, here we have created this separately. So we have given day-wise frequency. Okay, because the event timestamp was missing in our data set. But when in real life, when you will get this data, then normally you will be knowing, okay, what time this record is created. So you can record the same time at your data set. Okay, so that's why like two records can occur simultaneously. Okay, so this will be same, but how you to uniquely identify that time, a patient ID will be needed in patient ID, or it could be any unique ID, right, based on your data set. So that's where I have created patient ID. So now with combination of these two, this record will be unique. Even with patient ID also, this will be unique. Okay. So now predicted data set is created, target data set is created. Okay. So now what the last thing in data preparation we need to do here, as I said, we need in the Parquet form, because Feast accept this in Parquet form. So we'll convert this into Parquet format. Okay, so let me do that. Dot to Parquet. And we can define a path is equal to predictor df dot Parquet. And similarly for target df. If I run this, then we have two data set created. Okay, and you can check in your folder also, like this predictor df dot Parquet and target df dot Parquet just now we created. Okay, even if you go back to your folders, then you will see here. So we have this and this newly created just now. Okay, now coming back. Okay, so this I can close. Okay, and this I simply created. Okay, yeah. So now what next? So now we have our data set ready with us. Okay. So because see here I have not done feature engineering, I have not done other pre-processing stuff, okay, which is required for model training. So that I'm assuming you will do. Okay, so that's not the agenda for today's discussion. right? So I assumed we had clean data set, and what was missing with respect to feast, so that I have added like event timestamp and patient ID. These two columns I have added. Okay, now from here feast work will start. So what we need to do, so we have already installed, so I have already installed the feast as a next step. But if you have not installed, then of course you can do pip install feast. If you run this command, then it will install the feast. Okay, and one more important thing, guys. So let me check the feast version, whatever I'm using. So how we can do feast space version. Okay. Why this is important? Because see, feast is an open source library and lot of things are still evolving. Okay. So there could be a reason like maybe 1 month or 1 year later, you are watching this video and you are trying this notebook. Then there could be some feature, maybe here I'm using feature, then there could be there in future they might change it to field, right? So these small changes may occur, and that's how if you blindly run this notebook, then it might produce some error. So that's where I'm telling, okay, in this notebook I'm using this feast version 0.21.3. Okay, so you also install the same version and then this notebook will work smoothly. Fine. And now the next thing is like feast init. So what feast init will do? So feast init will it is nothing but like it will create three different kind of files. So let me first do it and then I'll explain it. Okay. So how you can do? So simply feast init, and you need to define a repo. So feature underscore repo. You can give any name. Okay. So it will create a feature repo directory. So here I need to give this exclamation sign as well. Okay. So see, you got the message creating a new feast repository in the same location, feast repo. So now I can come here and see feast repo newly a repository got created, and it will have this content like data init.py, example.py, feature store.yaml. Okay, and one more thing I will show you, like if you are running feast, with -m like that, feast init -m feature. So let me give another name. Okay, then it will create a blank empty repository. So like data and example.py, these things will not be there. So it has created another repo one, okay, in the same location here. So see feast repo one, feature repo one, right? And here it will have only feature store.yaml, not other. Okay, so other thing you can create manually if you have already worked in so many exercises you have done in feast. Okay, so you know what structure you need, right? Then you can create by yourself. Okay, but here if you do normal feast init, you can define the repo name, then it will create this structure. So inside data, you can create your data. You can keep your data set. Okay. And init.py is a normal constructor, the empty file, and then example.py. So this I'm going to create. Okay. For you for this diabetes data set. So what this contains basically, so this will contains your feature definition, like feature metadata. In other term, like what feature you want to store as part of feature store. Okay, and later you will be serving them. Okay, so that's the content of this example.py. This is nothing but a feature metadata file. Okay, and then the fourth one we have like feature store.yaml file. So what it does, it will tell you, okay, what is your project, like feature repo, okay, and then registry DB, what is the location of this. So what registry DB is, it will internally hold the feature metadata, what is coming from that example.py. This example.py. Okay, so this I will name at feature definition.py. Okay, so here I will be defining the feature definitions. So in a moment it will be clear. Okay, and then those will be stored here. Okay, and then we have provider. So there are different types of providers. So let me go here and I will quickly show you. If you go to quick start, so it is very nicely documented, guys. So please refer this one. Okay, so here if you come, so same after creating a repo, so they have done feast init. Okay, and then it will create a repo. And then if you come here, then feature store.yaml, so it will have this structure. Okay, so what is this all about? So project I explained, registry I explained, and then provider. So it could be different types of provider, for example, local, GCP, and AWS, and even some other custom provider as well. Okay. So with local provider, use file as an offline store and SQLite or Redis as an online store. So offline store, like where you keep your training data set. Okay. And then we have another online store where you keep your like online, the data which you will be using for model serving for real-time prediction. Okay, so that in low latency features can be provided for model serving, so that it is much faster. So for that we use online store. This is the theoretical part again. So once you are going through the theory of the fish, then you will be more clear. So file source as an offline store and SQLite or Redis as an online store. If you use a GCP as a provider, then you have option to use BigQuery, Snowflake as an offline data store, and this Google Cloud Data Store or Redis as an online data store. If you are using AWS as a provider, then you can use Redshift or Snowflake as an offline data store with DynamoDB or Redis as your online data store. Okay. And even you have some options available to define your custom provider. So like here adding custom provider, if you go, then here you can like at the top, you can define your provider. Okay. And then you can then use the same provider here. Okay. So this is the thing. Fine, guys. So this is the part of feature store.yaml. So here. Okay. So now for this exercise, I'm going to use local one. Okay. And then online data store will be our like local data, and online store.db. Here it will store the data set. Okay. Feature values, content basically. Okay. So that's the all about this feature store.yaml. Okay. So now this is the structure. The most important thing is like example.py. So here I am going to rename this feature definition, feature underscore definition .py. Okay. And if you have created empty repository, then you can create here feature definition.py file, Python file. Okay, because as a next step, when I'm going to do feast apply, then it will look for that py file here, and based on that, it will create a registry.db from those feature definition. Okay, so that py file should exist inside feature repo. Okay, and then together with feature store.yaml, these two should be in the same folder. Okay, so here I'm anyway using this one, and I will open this one, and I'm going to delete all the content. Okay, so this whole content I'm going to delete, and I will create freshly for you. So this libraries import statement I kept because I will be needing them. And then let me create this. Okay, so now feature definition. What are feature definitions? So like feature definition means here you are going to define the metadata part, means mainly the features which you want to store. Because not all features could be important. You want to store only some features, right? And then later you want to make them available as an online store. So how you can do this? Okay. So first we need to define a like primary key, primary key, so that uniquely identify the features. For that, we have, we can name it anything. This is a normal variable. So here, because we have a medical data, so I will write as patient. So then we'll create a entity. Entity is nothing but acting as a primary key. Okay, so we can define a name as patient ID. And then we can define value type, means the data type. Value type is equal to value. Okay, type is not working here. Anyway, I will type it. Value type dot int 64. Okay, and then I can also define description. Description is equal to, this is like ID of the patient. And then I will close. So this is the entity got created. And later I will be using this. Okay. So now another thing is like feature definition. So inside feature definition, we define the feature view. Okay. So what this feature view will do. Okay. So let me give data frame underscore feature. You can give any name. Okay. So it's equal to feature view. And then I have to again define certain parameter to this. So what all parameters needed basically? So we need a name for this feature view. So I can name it like predictors df, predictors underscore df underscore feature view, because I will be creating a feature view for target df as well. Okay, so I'll be creating two feature view, and the name happen and then TTL. This is again another important field like time delta. So I am going to explain what is this all about. Okay, so yeah, let me write this schema. So what is inside schema I'm going to write? So defining the different features basically. Okay. So name is equal to. So here I'll be using all the features from our like just a minute. Yeah, these features. Okay, what our data set has. So I'll be using the same features, and then I need to define the data type. So let me copy this. Okay. So I'll be copying features from there. Okay, so one extra happens. So let me delete this, and then this is actually float. So this you can check from here. So if you do basically dot info, okay, then you will get to know the data type, basically all the features. So here you see this is the float, BMI is float, and diabetes pedigree function is float 64. Okay, so let me define the same thing here. Make it 64 because I'm using that one field. Yeah, so I hope yeah. So now what is so in feature view, we have the name parameters, the normal the name of the feature view, and then TTL. What is this TTL? Time to live, basically. Okay, so this TTL is very important at the time of like online store, when I will be pushing this data for online store. So that time basically so here see this 86400, these are the seconds in a day. Okay, and then one means I'm interested to do the prediction on today's data. Okay, like one day latest one. If I define 2 here, okay, then in online store, it will keep data for today and day for yesterday for 2 days. Okay, if I am typing 3, then it will have today, day for, I mean today, yesterday, and day for yesterday. So last 3 days data. Okay, so likewise it will have. Fine. So let me have it 3, or okay, let me do it 2 only. You can do anything. Okay, you can try it out. So this is the time to live. Okay, and then entities, to this patient IDs, this is coming from this. So it should have same thing, right? This is the entity, and then a schema. So will we it internally it will be having a table, feature table basically, and it will have columns like name. So let me do this. Okay, so name, pregnancies, and type 64, glucose, blood pressure, skin thickness, all those things. Okay, and I have shown this from where I have picked this from the predictor data set. Okay, so this becomes our feature view. What else I need? Basically, I need some more details here. So like a source. Okay, so source I have not defined, so I need to define the source, because from where it will get this data, right? So source will be like the data warehouse where your original data is stored. Okay, so but here locally I don't have any data warehouse, so I'll be saving that data in somewhere in local folder, and that I'm going to read. Okay, so this is nothing but the file source. So let me write it fully. File source. Okay, is equal to let me write it 1 or maybe for, yeah, 1 is equal to file source, because I'll be creating one more file source. That's where I'm writing it 1. Okay, so file source, and path is equal to uh, so our predictor data set path. Okay, so where I have stored our predictor data set. So where it is, so it is one label out, so it is stored. So we are inside this, but our data is here, right? So this here. So what we can do, okay, so one label outside. So where we are, so we are inside the feature repo, right? And our data is here. So maybe what we can do, we can simply copy this data and place it inside data folder. Okay, then it will be easy to pick it. And this we can, this is of no use, okay, because if we want to use the default driver stat, then we can use this, but we are using our own data set. Okay, so I will keep it here. So now going back. Okay, so what we can do, data slash and predictors is called df.p. Okay, so this is the data set, and then here we need to add one timestamp column. That is event underscore time stamp underscore column is equal to so this is our file source, and that we need to give it here, source file source 1. I hope this is clear. Okay, and then we need to give like online is equal to true, because we'll be sending to online as well. And that I have defined right what data will be sent to online, that is TTL, based on TTL. And then if we have any tags, then that also we can define for like filtering purpose. Okay, but that I'm not going to use for now. Okay, so this is your one feature view. Fine, and now we'll be defining the target feature view as well. Okay, so here let me write a comment like predictors feature view, and then we'll be defining the target feature view. So for this as well, we need to define the target source. So let me write this as well. Okay, and then source. Anyway, we don't need this one because we are renaming it. Okay, target source and file source will be like target. Let me quickly verify the names. It is predictors and target find. Okay, so target df and event timestamp anyway we have added in both the cases, so that's fine. And then let me create a feature view. So let me quickly copy this part, and here I don't need all of them. Okay, I need only one, and here this will be target source. And then here inside your data we have anyway defined here, this is target df, we can name it. And time to live is fine, and patient ID is fine. And then here we have what is target column name, outcome, and this is in 64. Fine. So that's it. So here you guys see we have defined our feature definitions, right? Nothing else. Just we have defined the feature definition, and these are the libraries we need, like feature view, field, all these things. So we are using it. So if we have not done any syntax error, then it will work. If any syntax error comes, then also we'll tackle. We'll see. Okay, but I hope logic is clear. So I have defined the file source for predictors. Okay, and then we have defined the predictors feature view. Okay, and entities for feature like primary key. And similarly, we have defined target source for target data and then target feature view. Okay, here we need to rename it like target, otherwise it will be same. Okay, you can give any name. Okay, just so that it should be meaningful, so that later you can easily recognize, right? So now we have defined our feature. So like here this feature definition is done. There is no need to change anything here because we are using local provider. Okay, and now go back to your original notebook file. So we have done init. Okay, after init we have created feature repo, and then we have defined the feature definition as well, and the we understood feature store.yaml as well. Okay, now what is that? So this is not used, we'll not be using. I have anyway explained you. Okay, what is next? So we have updated feature store YAML file. This, yes, we have updated. Defined feature definition in Python file inside feature repo directory. This also we have done. So till fourth step we are done. Okay. Now next thing is like feast apply. So what feast apply will do, guys? Okay, we need to understand. So let me first do it and then I'll explain. Okay. So feast apply. And guys, remember one thing, we need to do feast apply inside the feature repository. And if you see right now where we are, so we can run this pwd. So we are inside feast live demo. Okay, this is our project folder, but our feature repo is this, right? So inside this is our feature repo, right? So let me delete this because this is not needed. Okay, but it has content. Okay, so let me delete it from here. So this is our feature repo, right? But in PWD, we are inside this. So we need to go inside this, and then we'll have feature definition here, right? And please guys, make sure there should not be any other PY file, okay, apart from this feature definition, because it will look into all the PY file, and from there, it will try to create a feature definition, feature registry, okay, registry DB. So let me close this. Okay, yeah. So we are inside this directory, but to apply feast, we need to go inside feature repo. Okay, so let me go inside that. We can do normally cd and then feature repo. Okay, Now we are inside this feature repo, and then we can do fist apply. If we have not done any syntax error, then it will work. So basically it will register the features in the feature store. Okay, so what it is telling? So description, ID of the patient. So line number 9, something we have done. So let's figure out that one. So line number 9, okay, we need a comma here. So let me again execute it. Okay, some more error. So what it is telling, name int 64 is not defined. Okay, so int 64. So in 64, okay. Here we can have this. Okay, so let me save it and here as well. Okay, let me run it again. Yeah, so now you guys see it has created an entity patient ID, and it has created a feature view predictors df feature view and another feature view target df feature view, right? And it has also created a SQLite table feature repo predictors df feature view. Okay, for to contain the data for predictors df and for target df. Okay, so now we have this feature store is created, right? So now the next the simple part is like generate training data set. Okay, so how to generate the training data set? So for that as well, what we need to do, uh, so training data set will generate from the feast, that is from feature store. Okay, so for that also what we can do, we can import some libraries. So here, if you see, so these are the libraries we need. So from feast, import feature store, because feature store will be using to generate the training data set. Okay, and then save dataset file store will be using this to save our generated training dataset so that further we can use it. Okay, and now let me define the store. So store is equal to feature store, and here you need to give the repo path. Repo path, okay, is equal to, and so repo path is equal to like wherever your feature repo is, but we are inside the feature repo, right? We are inside this, then you can mention a dot. If your feature repo is somewhere else, then you can mention that path. Okay, I'll mentioning dot because we are already inside feature repo. Then we need to define the entity df. Okay, so entity df is nothing but the like target data frame. Okay, so pd dot read parquet file, and then path is equal to data. We have kept inside data, right? So target underscore df dot parquet. Okay, so this is our entity data frame, and then we need to have training data set, right? So training data set. So store dot get underscore historical data, get historical features. So the feature store provides this method like get historical features. Okay, and here you can simply define what all features you need. So it's not like you need to define all the features from the feature definition, feature view, right? You can define whatever you need, right? So here let me define. So like, of course, this training data should contains the target data set as well as predictors both. So target data set I'm taking from entity data frame. Okay, and then we need to define features, what features I'm interested in. So feature is equal to like this. So this is the syntax, and here what you need to do, you need to define the like feature view, name of the feature view. So what is the feature view? Predictors underscore df underscore feature view, right? And then column your column, so whatever you need. Okay, so let me define that quickly. Okay, so next one will be glucose. So these features should come from that feature definition. So you can define whatever you need. It's not right, you need to define all. You can define whatever you need. Okay. Hmm? Yeah. So we have defined these features. And then we'll be saving it so that we can read it further. So we can save it. So data set is equal to store dot create save data set. So what, from where? From training data, right? Training data. And we can give the name. So name is equal to like diabetes underscore data set. And then storage saved data set file storage. Okay. And here we can define the path. So path, I want to keep it here. Dataset dot parquet. So see here in Feast, as of now, most of the thing like data related happens in Parquet format. So that's where you need to convert everything in Parquet. So let me run it. So here, see guys, we are generating the training data set. So we have created the feature store. Now from that, we are generating training data set. So for that, I have defined entity data frame. What it will contain? It will contain the target data set. And then from that target data set, with the help of get historical features, we can create the training data set. So this will be your content of your, it's not only column name, it will have data as well. After running, I will show you the content of training data set. Okay, we have generated training data set, and then what I'm doing it, I'm just saving it to the Parquet format in the file storage. Okay, so let me run it. If everything is right, then it will work. Okay, so there is some problem. Let me see what is there. Okay, fine. Yeah, so we are missing with comma. Okay, what else? Okay, duplicate where I left. Okay, so this is duplicate. So let me remove it. Let me rerun it. Okay, so now it worked. Okay, so now let me show you the content of training data. So if I paste it and do to data frame, okay, then you will see. Okay, so we have see with outcome and event timestamp, I have fetched the complete data set. Okay, so it has 767 rows, all the data set I have fetched. Okay, in training data set, you can remove this And also you can check if you are not interested in that one, then you leave that and see age column is okay. Just I need to rerun it. Now you see age column is gone, right? So you can define whatever feature you are needed in the training one, and based on that it will do. So now, okay, suppose I'm interested in all the column, but I have shown you, right? You can define whatever you need. Okay. So now if you go back here and inside feature repo and inside data, you will see this newly created within a second ago, right? So diabetes dataset dot parquet file I have created, right? And driver state I can delete because this was the default one created with fist in it, which I not needed. And even you see here registry DB is created when we perform fist apply. So out of fist apply, I reference so this. Okay, so registry DB got created, and then this online store DB. So these two things got created out of this fist apply. And then the moment we generated training dataset, we got diabetes dataset just now. Okay. So now we have training dataset available. So now quickly create a model. So I have already written the kept the code for model training. So because that's anyway model training part, I'm not explaining here. So the agenda is to explain the feast part. Okay. So let me quickly explain what is happening here. So inside model training, so this is anyway feast store, feature store will be needing to read the data, and then sklearn like for trend test split, and then logistic regression I'm going to use, and job list to store the model. Okay. So here like feature store, like the feature path. So again, as I said, we are inside the feature repository. So dot will work. If you are in some other repository, your notebook, then you can give the complete path for that feature repository. Then training DF. So training DF in the previous step, I have saved it here inside data. Then you can simply read the training DF, right? So it's store.get saved dataset. You can define the name and .2df. Then so this name. So we have given here, right? This name. So this should be the same. Okay, and then you can read it easily. And then from this, we can simply make it X and Y separate out like predictors and target. And then we can define the labels as outcome, event timestamp, and patient ID. Okay, so this what we are doing here from the training DF, we are deleting this, we are dropping this because we don't need this in X variable, right? Because event timestamp and patient ID at the time of creation, I told this will be needed during your serving. Okay, but during model training, you don't need them. You just simply delete, and outcome will anyway be stored in target one. Okay. Then simple trend test split, and then a logistic regression classifier, and then fitting. And then we got the model trend, and then I'm saving it as a model.joblib file. Okay. If I run this, then it will store the model. Okay. Okay. Yeah, it has created the model. And if I go here and if I refresh, then where it is? Yeah, here in the feature repo, it has stored. Okay. Inside feature repo, because we are inside feature repo, right? So our model got saved, and now we need to prepare online feature store, right? So we got the training data, okay, from offline feature store. Now we need to do the online feature store. So to push the data, so what online feature store, how we can get the data in online feature store? So for that, we need to load the features to online store. How? So there are two methods. One is like materialize, and another is like materialize incremental. So in materialize, what it will do, materialize will load the dataset latest features between 2 dates. 2 dates means the range, right? We need to define the start date and we need to define the end date. In between those 2 dates, it will load all the features to the online store, means for prediction. Okay. Or if you are doing materialize incremental, then what it will do, it will load the feature up to the provided end date. Okay, so like this. So if you have defined end date as this, okay, then so from the beginning, it will load all the feature till here. It means all, it will load everything. But here there is one thing to note, guys. It will load feature like when you have run the feast materialize last time, starting from there till here it will load. Okay, suppose I am running this command and 2 days later again I am running this command. So 2 days later, whatever will be the date, so from today till that date will load. Okay, so means last time when you have ran the feast materialize, from starting from there till this date, so that's what feast materialize incremental will do. Okay, so that every time you get the latest feature in your online data store. Okay, so how we can do, let me quickly type it. Okay, so what you can do here, again the same thing, we need those libraries. So if you have already imported these libraries within the same notebook, as I'm using the same notebook, you can, it's fine. But because step by step, for each step you can create a separate Python file. And of course, if you are creating a separate Python file, please keep them outside your feature repo. Don't keep any other .py file inside this. Okay, otherwise feast apply will create a problem. Okay, so if for each step you can create a separate file, you just copy paste that code. Okay, so that is the reason I'm importing this again and again. Otherwise, in the same notebook, in the above also I have imported, so you don't need to import it this again. Fine. And then what we can do is store dot materialize incremental. I'll simply copy this. And then we can pass end date t is equal to date time dot now. Okay, so current. So what it will do, it will load all the features, okay, to the online store. And all the features means like TTL. So now if you remember here, I have defined TTL, time to load. Okay, so for 2 previous date. So start day will be for first time feast initialization, start date will be for 2. And next time it will be from the last feast materialized date. So let me quickly run this if everything is fine. So incremental is not defined. Okay, so it is underscore, not hyphen. Yeah, so now you see. So materializing 2 feature views. So 2 feature views means the first one is like target and another one is like predictors basically, right? So 2/27 for this date. So predictors df feature view from 25 till 27, because we have defined time to live is equal to 2. Right, so that's where I was telling it will push last 2 days features to the online store for prediction. If you, so like here in 2, right, if you define 3 here, then it will push 3 days. Okay, last 3 days, I mean from last 3 days to today, so this date time. Okay, so that's what this means. Now we have our features available in our feature store. So now it's time for prediction. So let me write the code for prediction. Yeah. So here how you will get online features. For that, again, we'll import these libraries because we need feature store to load online features. We'll be reading the data file. So we'll be using PD as pandas as PD, and then we'll be loading the saved model. Okay, so that for that purpose, I have used joblib import load. Okay, and now getting our okay, so now here again define the store repo path as dot. Okay, and then this again wherever your repo is, you need to define that complete path because we are already inside the repo. Then we are defining dot, and then feast feature. Okay, so here again I'm defining the features. So this feature view, then colon feature. So that's the syntax. One more thing, guys, and now I remember. So you can even combine multiple feature view if your features are stored among different feature view. Okay, then you can combine. So like here you can write. I mean, if suppose this is coming from v2 feature view 2, then you can write that also. Okay, so it will take care. internally. Only the thing is like that feature view should be defined in feature definition. So now for getting the latest features is equal to store.getOnline feature. Using this API, you can get online feature. You simply need to define the features. So it is coming from here, feature list, and then entity rows. So what is entity rows basically? So entity rows means from these data set, it will fetch only the features for this patient ID, these two patient IDs for prediction. Okay. So it will fit only these for these two. Okay, and make sure you pass only IDs which are present in these two dates, like 25 and 27. If any, so if you look for the complete data, this is our data, right? So our online store contains data set only starting from 25 to 27. So you can do the prediction on 765, 766, or 767. If you do the prediction on 764, it will say data doesn't exist or any other error. Okay, null type error. Okay, it will give, because 764 24th data is not available, because in prediction we'll do prediction only on current data, right? On some set of date. Those set of date like time to TTL we have defined for last 2 days, right? So this and this. So starting from last 2 days till current date. Okay, it will have. So that's 25, 26, and 7. Fine. This is anyway today. So we have defined features, and then 767 and 766 will be available in that last 2 days. Okay. So starting from last 2 days, so means day for yesterday and yesterday and day for yesterday, and then again datetime dot now, that is today. So ultimately it will have 3 days. Okay, so any of 3 days you can put the IDs here. So I'm just defining 767, 764. You can have 765 as well. Okay, and then again converting features to a data frame, pd.dataframe.from dict. So here we are passing these features. Okay, and then we need to load our model. Okay, and then this part we can do as part of this. Okay, so here we are simply getting the features from online data store. So if you simply print this, then you will have 2 data set. I mean 2 records. See here, 767 and 766. And for that you need to do the prediction. So for that you need to load the model, and then you need to pass that in the predict function. Okay, and then you can print the prediction also. So it will print the array of classes 0 or 1. So let me run this. Yes, see, 0, 0. So for both of them, it is predicting as a 0, means no diabetic, right? So that's all about feature store, guys. So all the steps I have covered, starting from like preparing your data, then initializing the feast, then defining the feature definitions, which will hold the features metadata. Ultimately, backend it will create a feature view, register and deploy the feature view, and that will exist inside the registry DB. Okay, inside. So this registry DB. So whatever path you give, it will go inside that. And I'm giving inside data, so it is residing here. Okay. And then next step, you need to you did feature feast apply, then it will create. I mean, it will deploy the features, and then next you need to generate the training data set, and then you can simply generate the online data set, and then you do the prediction. Okay, so that's it for Feast as a offline or online data store. So hope it has cleared your doubt, practical point of view. But still, if you have any question, then feel free to write in comment, and I'll be happy to answer them. Okay. So, and if you like my videos, then please don't forget to subscribe my channel for future videos, and please share with your friends. So thank you.